All right, this is a rough one. Identify the focus and the directrix. The best way to do this is write this guy in vertex form. It's not in vertex form. Vertex form is this: y equals x minus h squared plus k. Now, there's usually an a in front of it, so I'm going to actually throw that a in front of it. That's vertex form. What we're going to get with all of this is specific things that'll help us, like these specific letters. Once we find out what A, H, and K are, that'll help us find the focus, the directrix, before that the vertex, all that important stuff. Now, what we also recognize before we even begin is that this is a positive leading coefficient, which means it opens upward, which means the focus lives up here and the directrix lives down there. Okay? So, having said that, what we're going to do is completing this square in order to get this in vertex form. First thing that we're going to do is we're going to pull a 2 out of just these first two terms. So y equals 2x squared plus 18x, and then plus 16 is just going to linger. 166 numbers. It's just going to linger over there. This is where it gets weird. We're going to take this guy and we're going to complete the square with this parentheses only. So what you do is you take half of the number in front of x, 9, square that, 81, and add that in here. Okay, so now we have y equals 2x squared plus 18x plus 81. Now here's the issue, right? I can't just willy-nilly add 81. And the reality is I'm not actually adding 81 to this whole function. I'm adding 81 times 2. So by adding 81 inside the parentheses, I'm actually adding 162 to the entire right side. You're not allowed to just randomly add 162 to the entire right side, so we're going to subtract 162 over here. Now what this allows us to do is it allows us to say y equals 2. This is a perfect square trinomial, so x plus 9 squared plus 4. Now we are in vertex form. A is 2, h is negative 9, and k is positive 4. Okay, so that gives me a vertex of negative 9, positive 4. With that information, what we have to do is we have to find something called P. Now, A, this A right here, is the same exact thing as, actually, let's do it this way. Let's say P, let's just do it this way. It's easier in my opinion. I wanted to find A, but let's find P. P is 1 over 4A. So P is going to be 1 over 4 times 2. So P is going to be 1/8. Using this information, we can now find the focus and the directrix. The focus is a point here, and that point is H, because again, it kind of lines up nicely with the vertex. So H, and then K plus P. So in this case, the focus is going to be h, which is negative 9, k, which is 4, plus 1/8. And pretending that 4 is 32 over 8, we could say that this is 33 over 8, and that's going to be our focus. Our directrix is a horizontal line. And the horizontal line for the directrix is given to us by the equation y equals k minus p, because it's the same exact distance from the vertex that the focus is. So y equals k, which we found out to be 4, minus 1/8. And if we again pretend that 4 is 32 over 8, we get 32 minus 1, which is 31 over 8. Y equals 31 over 8 is the directrix. So these problems, not the easiest guys in the world, not the easiest cats on the planet, but we did it. Graph y equals negative parentheses x minus 3 squared minus 1. This is a parabola in vertex form. Vertex form is y equals a parentheses x minus h squared plus k, where the vertex is going to be the point hk. So, since negative 3 is negative h, that means the vertex is going to be positive 3. And since positive k is negative 1, negative 1. Now that's going to be our starting point. 3, negative 1. You can graph these any way you want. But what I like to do is, now that I know what my vertex is, now that I know what my starting point is, I like to pick a few points around it. So I'll pick like 4 and 5. I'll pick, and by the way, if I pick 4 and 5, since this is a parabola, and by the way, this is also a parabola that opens down, since that's my vertex, whatever 4 is, 2 is going to be also. And whatever 5 is, 1 is going to be also. So let's pick x values of 4 and 5, and if the Lord leads us, we'll do 6, 4, 5, and see what y equals. So if we plug in 4, we get y equals negative 4 minus 3, so that's going to be 1 squared minus 1. 1 squared is 1, negative 1 minus 1 is negative 2. So 4 is going to be negative 2, which means 2 is going to be negative 2. Plug in 5. We would get 5 minus 3, so negative 5 minus 3 is negative 2 squared minus 1. So that's 4. Negative 4 minus 1 is negative 5. So if 5 is going to be negative 5, that means 1 is going to be negative 5. And that's enough information for me to draw a nice looking graph. Nice little curve there. I'm not the best at drawing these things, so bear with me. But I'll take a little bit of credit for that. That's not so bad. That's how you do it. Graph y equals 1/4 x squared plus 1/2 x plus 9 over 4. You know, there's multiple ways to do a problem like this. But what I like to do is I like to find the vertex and then go from there. Okay, so if I find the vertex, what you do is you say x equals negative b over 2a. You label the number in front of x squared a, you label the number in front of xb, and you do a little bit of math, which is not going to be so pleasant here. 1 over half over, by the way, I forgot the negative, 2 times 1 over 4. That's actually pretty nice. Because you get negative 1/2 over 2 times a quarter is a half, and so a half over a half is negative 1. That's nice. So if x is negative 1, then in order to find the other part of the vertex, we plug that negative 1 into the equation. So y equals 1/4 negative 1 squared plus 1/2 times negative 1 plus 9/4 period. So that's going to give you negative 1 squared is 1, so 1/4. A half times minus 1 is negative a half. And then you got plus 9 and a quarter, so that's going to be 9 1/4 still. So this would be, let's turn this into 2 over 4. 1 minus 2 is negative 1 plus 9 is 8. So 8 over 4 is 2. So our vertex is a nice negative 1, positive 2. So let's put that out there. Now this is an equation. This is an equation that that opens upward because that. Now I know what's going to happen. Since my number in front of x squared is a quarter, we're going to get quite a bit of fractions here, and that's okay. So let's pick nice numbers and plug it in and understand that whatever point that I pick over here to the right side of the vertex is going to be mirrored over here. So what we'll do is we'll pick 0, and then we'll pick 2, and then we'll call it a day and see what our graph looks like when we do that. All right, so let's make ourselves a little table with 0 and 2. Okay. Whatever 0 is, negative 2 is also going to be that. And when I pick 2, since 2 is 1, 2, 3 units away from negative 1, 2 is going to be the same as 1, 2, 3, negative 4. So 2 is going to be the same as negative 4. Okay, so let's pick 0. Let's plug in 0, x, y. Plugging in 0 is going to be really nice. I get 0 squared, which is 0, plus half of 0, which is 0, plus 9/4 is 9/4. So I knew I would get like some kind of fraction. So at 0 and 2, I get 2 1/4. So at 0, so basically, like I said, this is going to open wide. At 0 and negative 2. Oh, he's got a little red nose and eyeballs. Like Rudolph. or a little mouse. If I plug in 2, I get a quarter of 2 squared, which is 4, plus a half of 2, which is just 2, plus 9 quarters. So you'll be 1. You'll also be 1. And you'll be that, what is that, 2 1/4? So you become 4 1/4. So at 2, we're at 4 1/4. At -4, we're also at 4 1/4. And using those few dots, I'm comfortable with sketching out a graph that's never going to be perfect. Okay. Is it 100% accurate? Nope. Is it accurate enough? Yep. So we're going to go with that. Not so bad. Graph x equals y squared minus 6y plus 8. I am going to use the zero product property and find the vertex. And oh, by the way, this guy opens up sideways. And it's going to open up to the right because of the positive y squared. So in order to figure out what my vertex is very, very, very similar to figuring out what my vertex is when it opens up or down. Instead of saying x equals negative b over 2a, we're going to say y equals negative b over 2a. Okay, a is invisible 1, b is negative 6. So negative 6 over 2 times 1 is going to be negative negative, which is a positive. 6 divided by 2 is 3. So y is 2. How do I find my x? Plug in 3 for y and solve. So x equals 3 squared minus 6 times 3 plus 8. That's going to be 9 minus 18 plus 8. That's another 18. I don't want that many numbers, just an 8. Thank you very much. Negative 9 plus 8 is negative 1. So x is negative 1, so my vertex is negative 1, 3. So my vertex is negative 1, 3, bada bing. Now what I'm going to do is I'm going to use the zero product property to find where these lines are going to cross the y-axis. You see this guy right here is factorable. So if I set x equal to 0, I am now saying, hey, let's find out where these guys cross the y-axis. So if you think of two numbers that add up to negative 6 and multiply out to 8, you'll get two negatives, and those two negatives will be negative 4 and negative 2. So y minus 4, y minus 2. And according to the zero product property, the two numbers that make each parentheses equal to 0 are going to be 4 and 2 in no particular order. But this means I have 2 more points. When x was 0, I got 4, and when x was 0, I also got 2. So here's a point, 0, 2, 0, 4. And from there I can draw some points, but you know what, those are just way too close. I'm going to be very paranoid. Why don't I plug in 1, right? Why don't I plug in 1, and whenever I plug in 1, whatever I get, well, not 1, yeah, 1. Whatever I get here, I'm also going to get at 5. So why don't I plug in y equals 1. And by the way, when I plug in y equals 1, that's the same thing as plugging in 5. So plugging in y equals 1 is going to be x equals 1 squared minus 6 times 1 plus 8. X is going to equal 1 minus 6 plus 8, which is going to be negative 5 plus 8 is 3. So I get 2 more points. 1, 3, 5, 3. So 1, 3. Oh, wait, no, I don't. I got it backwards. It's 3, 1, and 3, 5. Oh, see, you have to be so careful with these. Oh, boy. Oh, boy. 3, 1, 3, 5. 3, 1. And 3, 5. Let's draw this out the best that we can. Well, I'm no artist, but I'll give myself some credit. That looks pretty dang good. Identify the center and radius. Well, this is actually a very friendly problem. We're given x squared plus y squared equals 49. This is the standard form of a circle whose center is 0, 0. And that formula is x squared plus y squared equals r squared. So right off the bat, we can say that the center is 0, 0. And if you're like, well, how do you know it's not 0, 0? Because this would be parentheses like x minus 3 or y plus 4. But since that's just x being squared and y being squared, we're centered at 0, 0. The other part is also not so bad. In order to find the radius, r squared is 49. So if r squared is 49, we're going to take the square root of both sides. Now, normally we would attach a positive or negative symbol, but since this is a radius, you can't have a negative radius. So the radius is just going to be the square root of 49, which is 7. So the center is 0, 0. The radius is 7. This is about as friendly as they get. Identify the center and the radius of this circle. Well, this is the formula of a circle whose center is not 0, 0. And so we compare that to x minus h squared plus y minus k squared equals r squared. Okay, the h and the k are going to be our center. Okay, that's going to be the center. So if negative 5 is positive h, that means positive h. Wait, did I say that backwards? If negative h is positive 5, then positive h is negative 5. Let's go with that. And if negative k is negative 10, then positive k is positive 10. That's going to be our center. Okay, not so bad. Our radius is going to be found by taking r squared and setting it equal to that 9 there. Okay, we square root both sides, but we don't attach a positive or negative because you can't have a negative radius. So the radius is going to be 3. So if I were to graph this, I would put a dot at negative 5, 10. I would go out 3, draw your circle. Easy peasy lemon squeezy. Identify the center and the radius of this god-awful abomination. This is terrible. This is not at all in the form that we want. The form that we want is supposed to be this. X minus h squared plus y minus k squared equals r squared, and we're not even close to it. So what we need to do is we need to do completing the squares twice. So we're going to put all the x's on the left side. We're going to put all the y's on the left side, and that number on the right side. So let's kind of do those two steps at once. Let's get rid of 364 by subtracting it. Let's add 26x. I know it's not the friendliest looking thing on the planet the way I wrote that out, but that's okay. And let's kind of color code things. So let's do the x's first because that's the order really that we want. We already have the x squared floating around here. So now it's going to be plus 26x, and then we'll leave some space. Okay? Next to it, we have y squared plus 28y, leave some space, and then it's going to be equals negative 364. All right, we can do this. Half of 26 is 13, square that is 169. So if I add 169 on the left, I add 169 on the right. Half of 24 is 14 square, that is 196. So if we add 196 to the left, we have to add 196 to the right. Big plus sign in the middle. So this factors out to x plus 13 squared. This factors out to y plus 14 squared. And you won't believe it, but according to Siri, these guys are 1. So now I have the form that I want. Now I have x minus h squared plus y minus k squared equals r squared. My center exists at hk. Okay? If negative h is positive 13, then positive h is negative 13. And I wrote down h again. Silly me. As you can tell by the nasally voice, I'm dealing with a bit of a cold. Like and subscribe and tell me the worst sickness you ever had. All right, that never works. Negative k is positive 14, which means positive k is negative 14. I did that one right. So that's my center. That's my center. My radius is found by doing r squared and setting it equal to 1. So you square root both sides. Don't worry about the positive or negative because you can't have a negative radius. And the square root of 1 last time I checked is 1. So the radius is 1. So, yeah, it's kind of a small circle, but hey, you know what? That's the type of friends you should have, so why not the type of circles too? Like and subscribe and name all of your friends in the comments. Please, you won't. Graph x plus 1 squared plus y plus 2 squared equals 25. This is a circle, and it's in a circle because it's in this form. X minus h squared plus y minus k squared equals r squared. Okay, now the center of my circle is going to be hk. So if negative h is positive 1, then positive h is negative 1. And if negative k is positive 2, then positive k is negative 2. So my center lives right here. Now I must find the radius. So r squared is going to be 25. So that's how I find my radius. R squared equals 25. Square root both sides. No need to worry about the positive or negative. Can't have a negative radius. And the radius is going to be 5. So probably the best way to graph this is you go right 1, 2, 3, 4, 5, put a dot. Go up 1, 2, 3, 4, 5, put a dot. Go left 1, 2, 3, 4, 5, put a dot. Go down 1, 2, 3, 4, 5, put a dot. All right, so this picture just magically showed up on screen. Oh, I don't want that. Transparent. Yeah, all right, let's see if I can make it expand from the middle by pressing this button. Nope. Yeah, drawing these out are not the best thing for me, so I'm just gonna do this, and I think that should, I think, yeah. I'll take it. There's your circle. Fun. Write the equation of the circle whose center is negative 11, negative 8, and whose radius is 4. Well, this is obviously a circle with a center not at 0, 0, so I'm going to write out the formula. X minus h squared plus y minus k squared equals r squared. My center is my h and k. My radius is my r. So what I'm going to do is just substitute things in, clean it up, and be done. X minus negative 11 squared plus y minus negative 8 squared equals 4 squared. So the double negative becomes positive, so x plus 11 squared plus y plus 8 squared equals 16. Not bad. Write the equation of a circle. Well, the formula of an equation with a circle not centered at 0, 0 is x minus h squared plus y minus k squared equals r squared. So let's see what we have. We have a circle whose center is 4, negative 3. So the center given to you by hk is in this case 4, negative 3. Which means h is 4, k is negative 3. Now, the radius is going to be the distance from the middle of the circle to the outside of the circle, which appears to be 2. So the radius is 2. No need to overthink that. So let's plug stuff in, clean stuff up, call it a day. X minus 4 squared plus y minus negative 3 squared equals 2 squared. Let's clean it up. X minus 4 squared plus y plus 3 squared equals 4. And there's your guy. Identify the center, vertices, covertices, foci, length of the major axis, and the length of the minor axis of the ellipse. It's a lot. Now you know this is an ellipse because it's in the form x squared over a number plus y squared over a number equals 1. Very similar to what a circle looks like, but since the fact that it equals 1 and you have denominators here makes it not a circle, it stretches things out a little bit. All right. Now, since the larger number in this case, 36, is below the x squared, we are going to compare this to x squared over a squared plus y squared over b squared equals 1. What I also notice is you're not adding or subtracting anything with the x and the 1, which tells us where our center is. But what we need to do before even we want to do that is find out what our a and b are. Not that bad. If a squared is going to match up with 36, that means a is going to be 6 by taking a square root. If b squared is going to match up with 16, then b is going to be 4 for the same exact reason, right? Now we also have to find this thing called c squared, or c, which is found by doing c squared equals, and this is going to be weird because it's going to go against everything you've been taught, a squared minus b squared, not plus, minus b squared. So c squared is going to be 36 minus 16, which is 20. You square root that, and c is going to be the square root of 20. Quick little fact, 20 is 4 times 5, so you can factor out like the 2. C is going to be 2 root 5. Now we have enough information to really label things, so we have to find out 6 of them. First things first, since you're not adding or subtracting either the x or the y, your center is going to be at 0, 0. Okay? Your vertices, whenever you're centered at 0, 0, are given to you, hold on, let me write it out, as either positive or negative a, 0. So in this case, the vertices are going to be positive a, which is 6, 0, and negative a, which is negative 6, 0. Those are your vertices. Your covertices, similar but different, are going to be 0, positive or negative b. So that's going to turn into 0, positive 4, and 0, negative 4. Okay, so those are your covertices. Your foci, when it's centered at 0, 0, are going to be positive or negative c, 0. So in this case, that's going to be positive 2 root 5, 0, and negative 2 root 5, 0. Your major axis, or the length of your major axis, is going to be 2 times a. So no parentheses needed. Don't know why I did that. So let's get rid of the parentheses. 2 times a, which is going to be, what did we say was 6? So 2 times 6, which is 12. That's the length of your major axis. And the length of your minor axis is going to be 2 times b, which is 2 times 4, which is 8. So, yeah, and we could use all this information to take this and draw a nice pretty little graph, but I don't have to draw that pretty little graph. I just have to list out all that fun stuff. Ellipses are great. They're awesome. Identify the center, vertices, covertices, foci, length of the major axis, and length of the minor axis of this ellipse. Well, when I look at this guy, I've noticed that the larger number is underneath the y part. So I'm going to compare that to this formula right here. X minus h squared all over b squared plus y minus k squared all over a squared equals 1. Okay, so since my larger number is always going to be a, I'm writing out this formula. Now, this is the formula where I have like a standing up ellipse where it looks tall and skinny versus short and wide. Okay, so that's what we're looking at. Some basic math. Negative h is 5, so positive h is negative 5. That's going to be important. Negative k is negative 1, so positive k is positive 1. B squared is 81, which means square root everything. B is 9. And a squared is 144, so square root everything. A is 12. Now we also know with ellipses that c squared is going to equal a squared minus b squared. A squared was 144. B squared was 81. 144 minus 81 is 63. So in order to find out what c is, you square root that, you square root that. That's the square root of 9 times 7, so that cleans up to 3 times the square root of 7. All right. Now with all that information, we can go over here and state the center, vertices, covertices, foci, length of the major axis, and length of the minor axis. When you are dealing with this form, the center is going to be hk. So in our case, the center is going to be negative 5, 1. The vertices, okay, the tippy top and the very bottom, are going to be h and k plus or minus a. So h is negative 5, so 1 plus 12 is 13, so that's one option. And then 1 minus 12 is negative 11. That's going to be our other option. Those are our vertices. Covertices are given to us by h plus or minus b, k. So we have negative 5 plus 9, which is going to be 4. K is 1. Negative 5 minus 9, which is negative 14. And that's going to be 1. Okay. We got our foci. That's going to be given to us as h, k plus or minus c. So h was negative 5. 1 plus 3 root 7. And negative 5, 1 minus 3 root 7. It's going to be our foci. Then we've got, what color haven't I used yet? Green. So we've got the length of our major axis is going to be 2 times a. So 2 times a is 2 times 12, which is 24. And the length of the minor axis is going to be 2 times b, which is 2 times 9, which is 18. And we could use all, excuse me, my goodness. We could use all this information to graph that on a coordinate plane if that's what we needed to do. We don't, but we could if we wanted to. We could if we wanted to. Graph this ellipse x squared over 4 plus y squared over 9 equals 1. Now this is an ellipse where the center is 0, 0. How do I know that? Well, I'm not adding or subtracting anything to x or y, so I can compare this to x squared over a number plus y squared over a number equals 1. Now, since the larger number is under y squared, we're going to call that a squared, and we're going to call u b squared. What that tells us about a and b is since a squared is 9, a is going to be 3, and b squared is 4, b is going to be 2. Square root. Okay? So the way we find out our vertices is, since this is a vertical ellipse, it's going to look tall and skinny. Okay, so the vertices are going to be up here. These are going to be your vertices, and your co-vertices are going to be over here. So really quickly, the vertices are always going to be the numbers that are attached to the longer arc, okay, the longer line. So that's going to be 3. So looking at this quickly, that tells us that my vertices are going to be 0, 3, and 0, -3. That would then make my co-vertices 2, 0, because it's attached to the B, 2, 0, and -2, 0. So using all the colors that I have, my center is going to be 0, 0. My vertices are going to be 0, 3 up here, and 0, -3 down here. And there's a stray mark that I accidentally left, so let's get rid of it. And then my co-vertices are going to be 2, 0, and -2, 0, like that. So let's try to draw this out to the best of my ability, which I'm really bad at. It's an ellipse, so you're looking at like an oval shape. So something that looks a little something like this, like a little potato. Started out weak, ended up strong. Look at that. So that's my ellipse, okay? Not too bad. Graph this ellipse x plus 5 squared plus y squared over 49 equals 1. Well, I'm going to rewrite this out to make this look friendlier, okay? This is going to be x plus 5 squared over 1 plus y minus 0 squared over 49 equals 1. Yes, this is an ellipse. Okay, now what we have here is we have our larger number living underneath the y part. Even before that, I noticed that I'm adding something to 5, so my center is going to be not at 0, 0, but at -5, 0. So my center lives right here. Now, since the larger number is underneath the y squared, this is one of those tall, skinny ones. Okay, so I would call you a squared, and I would call you b squared, which tells me that a, if I square root it, is going to be 7, and b, if I square root that, is going to be 1. Now, my vertices are going to be the numbers attached here, right? So let's focus on the vertices first. All right, if this is my center and my vertices are going to be attached to the longer sides, that means what I do is I go from my center, and since this is tall skinny, I'm going to go up 1, 2, 3, 4, 5, 6, 7 to put a dot there. Similarly, my other vertex is going to be 1, 2, 3, 4, 5, 6, 7 below it. That gives me vertices at the 2 points -5, 7 and -5, -7. My co-vertices are going to be attached to my B. That's only 1 unit away. Okay, that's only 1 unit away. So I'm going to go to the right one, put a dot there. I'm going to go to the left one, put a dot there. And my co-vertices are going to be at the points 0, -4. I have those backwards. -4, 0, -4, 0, and -6, 0. Now that I have all the information that I need to draw this out, I have myself a very tall, very skinny ellipse. And as you can see, drawing is not my expertise, but I'm doing the best that I can. But there it is. That's my ellipse. Twilight ellipse. Rewrite the ellipse in standard form. This is terrible. Basically, what we have to do is we have to move everything to the left side except for the number, which moves to the right side, and do like this double completing the square process. It's bad, but let's do it. Okay, let's add y squared to both sides like so. Let's add 2x squared to both sides like so. Let's add 8x to both sides like so. Let's leave that there. Let's subtract 52 from both sides, and it's a mess. Let's write out all of our x information first. We have 2x squared. We have 8x, leave some space. We have y squared. We have negative 16y, leave some space, equals negative 52. All right. This is where things get a little wonky. What I need to do is I need to do completing the square. Completing the square only works when you have nothing in front of x squared. So why don't I do this? Let's do the easy part first. Let's do the y's first to bring it all back. Okay? Nothing in front of y squared, hooray. Take half the number in front of your y. Half of negative 16 is negative 8. Square that and add that to both sides. That gives you plus 64 plus 64. Now that allows me to take that, okay, and make it y minus 8 squared, because it's a perfect square trinomial. What I have to do with this guy is I need to factor out a 2 first, which doesn't seem bad. Okay, and it's not too bad, but you'll see a confusing thing that happens in a minute. Okay? All right, now that x squared is alone, take half of 4, which is 2. Square that and add that in. So you get x squared plus 4x plus 4. Now that's attached to a 2 that's here. So if I were to add stuff to both sides, I'm not adding 4 to both sides. I'm adding 4 times 2, which is 8 to both sides. So now this turns into 2x plus 2 squared. All right, so let's drop down everything else that we have. 2 times x plus 2 squared plus y minus 8 squared equals negative 20 or 42, or negative 52 plus 64 is 12 plus 8 is 20. That's not pretty at all. Now ellipses are supposed to be equal to 1. So the last step that I'm going to take is divide everything by that 20 so that it is equal to 1. 2 over 20 is 10, so the left part becomes x plus 2 squared over 10. This guy doesn't change, plus y minus 8 squared over 20 equals 1. Definitely not the prettiest process in the world. Not at all, not even close. No thank you. Write the standard form equation of this ellipse. What I have is I have vertices that live on the x-axis. And I have foci that live also on the x-axis with zeros as my y values. What that tells me is since these guys are the same number and these guys are the same number but opposite, we have a horizontal ellipse with a center at 0, 0. That's the equation x squared over a squared, where a squared is the bigger number, plus y squared over b squared equals 1. You are my a. Okay, you are my c. Now the way I find out what b is I do c squared minus a squared minus b squared. C squared is going to be 3 times the square root of 19 squared, I'll deal with that, equals a squared, which is 14 squared, I can handle that, minus b squared. Okay, this becomes 9 times 19. Okay, because 3 squared is 9, and the square root of 19 squared is 19, so 9 times 19 is 171. That equals 196 minus b squared. Subtract 196, subtract 196, and you get negative 25 equals negative b squared. Okay, divide both sides by a negative. 25 equals b squared means b equals 5. Now, I'm not going to write out positive or negative because I don't care about positive or negative. I just care about the fact that b is 5. So if a is 14 and b is 5, I have enough information to wrap this problem up. X squared over 14 squared is going to be 196, plus y squared over 5 squared is going to be 25 equals 1. That's your guy. Write the standard form equation of this ellipse right here. Well, it looks like I have an ellipse that's short and wide, which means it's the horizontal version. Also, I don't have a center at 0, 0, so I'm going to write out x minus h squared all over a squared plus y minus k squared all over b squared equals 1. Okay, now my center is HK. My center here is -1, -1. So H is -1, K is -1. Okay, now rather than trying to find out my vertices and go crazy, what I do know is my A and my B are the length of half of my major or minor arcs. So basically, the distance from the center to the outside gives me A, and the distance from the center to the outside gives me B. Since this is short and wide, this is going to be my A here. So that's a change of 1, 2, 3, 4, 5, 6. So A is 6. And up here is going to be my B. So up 1, 2, 3, 4, 5. B is going to be my 5. Now I have all the information that I need to write stuff out and clean stuff up. So I have x minus -1 squared over A, which is 6 squared, plus y minus -1 squared over b squared, which is 5 squared, equals 1. So let's clean this out and finish the problem. X plus 1 squared over 36 plus y plus 1 squared over 25 equals 1. That is the equation of that ellipse right there. All right, it's time for hyperbolas. Vertices, foci, and center of this guy right here. First off, it's a hyperbola because of the minus sign and it equals 1. In this case, we have the y stuff happening before the x stuff happening. So this is how we label things in this matter. First off, this is a hyperbola that opens uppy downy. Not to be confused with Robert Downey Jr., famous actor. What we're going to do is we're going to compare this to y minus h squared over a squared minus x minus k squared over b squared equals 1. Using this information, we can say that if negative h is positive 8, then positive h is negative 8. And if negative k is positive 2, then positive k is negative 2. And if a squared is 36, then a is 6. And if b squared is 25, then b is 5. All right. We are going to need c. The nice thing about this is, unlike ellipses, if we want to find c, it's actually a Pythagorean theorem. A squared plus b squared equals c squared. So what was that? That's 36. Plus 25 is c squared. Those guys add up to 61 equals c squared, square root it. And you really don't get anything special except for the fact that c is going to equal the square root of 61. Nothing happens there. All right. Let's go in not the order that we're given. Let's do the center part first, just because the center is HK. And in this case, the center is going to be -8, -2. Okay, the vertices are given to us as h, k plus or minus a. Okay, so h is -8, k is -2, so we'll do -2 plus 6 is 4, -8. And then -2 minus 6 is again -8. Okay, so those are our vertices. Our foci, focus plural, is h, k plus or minus c. So there's our -8 again. Okay, k is -2, so we'll do -2 plus root 61. Then the other option is going to be -8, -2 minus the square root of 61. And yeah, there you have it. Hyperbolas, they're a lot. They're a lot. They're a lot. They're a pain. Let's graph a hyperbola. We have an x squared over stuff minus a y squared over stuff. So this is a hyperbola that opens up left to right. Okay, the horizontal version. So let's rewrite this really quickly as x minus h, or let's just not even write out the formula. I'll write out the formula. I'm so rascally sometimes. X squared over h, a squared minus h squared, a squared minus y minus k squared over b squared equals 1. Now what we see here is there is no number here, which tells us that h is 0. If negative k is positive 1, then positive k is negative 1. Okay? This is where it gets fun. If a squared is 20, then a is the square root of 20. Now, for graphing purposes, that is around 4.5. Around 4.5. Not exactly 4.5, but close enough that when I graph it, no one's going to yell at me for not being that good. That would make b the square root of 10, which is roughly 3.2. So what we could do is we notice that the center is hk. So in our case, 0, positive 1. Negative 1. Sorry. Our vertices are h plus or minus a, k. So in this case, we have 0 plus or minus 4.5, so 4.5, and then k is negative 1, and then 0 minus 4.5, so I don't need to write that out, I'll just write out minus 4.5, negative 4.5, negative 1. Okay, those are our vertices. That's the part that's going to be right here, if I knew how to draw these things a little bit better. My covertices kind of determine the asymptote stuff going on, along with other things like a over b, b over a, stuff like that, but we're not going to worry too much about that. So covertices, in this case, are going to be h, and then k plus or minus b. So h was 0. So k plus b would be negative 1 plus 3.2, so around 2.2. And then the other option would be 0, negative 1 minus 3.2, so negative 4.2. All right, so let's graph what we have. Our center is at 0, negative 1 here. Okay? Our vertices are negative 4.5, negative 1, so negative 4.5, negative 1. And positive 4.5, negative 1. So what's going to happen is it's going to go that way, but I want to be accurate. Okay? In purple, I have my covertices, which is 0, 2.2, so right around here, and 0, negative 4.2, so right around here. What I'm going to do is, using my vertices and covertices, I'm going to make a box like this. Okay? Like that. Now, the diagonals of this box give me the asymptotes, okay? Like the guidelines for my hyperbola. Okay, so I'm going to try my darndest to use the center and draw these diagonal lines which act as my asymptotes. Perfect? No. But will this help? Yes. Now my hyperbola, my curves, I guess, are going to be attached to my vertices. And I'm going to use these lines as guidelines. So I'm going to basically draw that. Okay, using my asymptotes as guidelines. All right, so there you have it. Fun stuff. Pardon my sniffles. I'm dealing with the cold here, but the job's got to get done. And we did it. Write the standard form equation of this hyperbola. All right, well, hyperbolas don't look like this at all. They're supposed to have like parentheses and squares over numbers and equals 1 and stuff like that. That's not at all what we have. So this is what we have to do. We have to do kind of like this double perfect square trinomial completing the square type thing. First thing we need to do is get rid of that 132 by adding it to both sides. Second thing we want to do is we want to write this in an order that seems to make sense. Like for example, see how that y squared is first? Well, let's put that first and group the negative 14y with it. Then what we'll do is we'll move the minus x squared over here, minus 18x gets grouped with that, and that equals positive 132. Now this is supposed to be subtracted. So I'm going to leave u the way it is for now, y squared minus 14y. And I'm going to factor out a negative. Negative x squared plus 18x, leave some space, equals 132. Now we do our completing the square. Take half of the number in front of negative 14, which is negative 7, square that and add that to both sides. So we'll add that to both sides. Take half of 18, square that, 9 squared is 81. However, if I were to distribute this out, this 81 isn't actually really an 81 on the left. It's a negative 81, so we have to subtract 81 from both sides. Okay? Now, what this does for us here is this guy is a perfect square trinomial y minus 7 squared. Minus this guy becomes x plus 9 squared. You happen to be 100. Isn't that nice? Last step, divide everything by 100, everything by 100, everything by 100, and our final answer is going to be parentheses y minus 7 squared over 100 minus x plus 9 squared over 100 equals 1. And there you have it.